Hi, everybody. My name is Dan Lindsay with NOAA NESDIS. Welcome to the Satellite Book Club Seminar Series number 242. Today's presentation is titled Tales from the Testbed, the 2025 Satellite Proving Ground HWT by Kevin Thiel. Our facilitator today is Jason Apke, who is a PhD research scientist at the Cooperative Institute for Research in the Atmosphere, or CIRA, in Fort Collins, Colorado. And he is also the AMS SatMock Stat Community Chair. A few reminders before we get started. This session is being recorded. See the pinned message in the chat for Privacy Act info. We're going to be doing questions, Q&A after the presentation. You can post your questions in the chat. If you're interested in presenting in the future, please fill out the form that's also linked in the chat. If you have any feedback on the session, please see the chat for the feedback form. Training assistance is available anytime you need it. Just contact Ross Van Til. And thank you to OCLO, the GEO programs, for their support. So today's presenter is Kevin Thiel, who is a research meteorologist for the University of Oklahoma CIWRO, serving as the GOES-R Satellite Liaison for the Storm Prediction Center and NOAA's Hazardous Weather Testbed. He leads the Satellite Proving Ground HWT each spring, works with SBC forecasters to integrate satellite data into operations, and investigates operational applications of the GOES-R Geostationary Lightning Mapper. Kevin received his BS in meteorology from Ohio University, and his MS and PhD in meteorology from the University of Oklahoma. So I'll hand it over now to Kevin for him to begin today's Satellite Book Club.
Thank you, Dan, and thank you everyone for joining me this morning. I'm really excited to get to talk to you all about this year's Satellite Proving Ground HWT. In the past, I've done these after the final report comes out, but I found that while we're in the convective season, strike while the iron's hot, and so be kind of providing a sneak peek, as you might say, of what we found in the testbed this year, some observations and feedback, and trying to provide some just new updates on some of the products that we were able to demonstrate this year. And don't worry about it, Dan. Yes, I get the Ohio University mix up all the time. But yeah, coming from Ohio University, the other big in-state Ohio school that's down the road in Athens there. So yeah, we'll go advance to the next slide and we'll go ahead and get started. So yeah, satellite demonstrations have been happening in NOAA's HWT since I believe about 2011 or so, that or 2009, and it's been right around the early 2010s. We've been doing these on an annual basis, looking to demonstrate new satellite products that have severe weather and also now DSS applications or decision support service. So we're looking at everything from data quality and the applications of these data, along with limitations and things that maybe can help with training, or how the product is even displayed, changing that within our test bed and seeing how forecasters react to that, along with future avenues for research and development. So we're really trying to be that interface between research and then the operations. We cover a pretty wide range of readiness levels. Typically, we're about the 3 through 8 range is what we tend to cover overall. But we don't have a set limit on that regard. So we really try to capture any satellite products that are looking for any kind of avenues for future development and accelerate that forward. We did 3 weeks of experiments this year in May and June. It was all virtual since NWS forecasters were unfortunately unable to travel. So in the top right corner, that's what we would have done this year and done a mix of in-person and virtual. And we reverted to all virtual this year and were able to meet many of our core objectives. We collected our data via surveys and blog posts and group discussions and whatever we could kind of get our hands on from the forecasters throughout the week. If we go to the next slide here, I'll show you how we set up our operations each day. We take our forecasters, we usually had about 6 to 7 per week. We put them into groups and we localize them to a weather forecast office across the country. By doing live operations, we can move our weather forecast offices anywhere. So on the left here, you can see the spread of offices that we went to. So maybe we visited a WFO near you. Each one had its own Google Meet, and so developers and the visiting scientists and observers could then hop between these Google Meets and observe what the forecasters were doing, and then also sitting in on that. We used Cloud AWIPS as well to feed our data sets, so that way everyone was on a standardized platform. We also did DSS events Tuesday through Thursday of each week to give forecasters additional applications as there, especially as the Weather Service continues to move more and more towards that DSS platform, along with issuing severe thunderstorm and tornado warnings too. We are a more relaxed form of official operations, so we are not as much focused on the exact timeliness of warnings, and that, but we really are focused on why forecasters are observing what they are and what goes into the warning. So we really are trying to get at the why in these cases, and that really provides a lot of power in the feedback from the forecasters. We did 12 days of operations across the 3 weeks, ended up being about 56 hours in total. And then you can multiply that by about 7 or 8 for each week for all the forecasters. We covered quite a bit. We did 22 unique CWAs, and we collected lots of blog posts and surveys, along with messages and graphics as well. And you can see our demonstration schedule there in the bottom left-hand corner. If we go to the next slide, we will to show by the numbers how much did we cover. So along with all those CWAs this year, we in total, forecasters issued 146 products. So we had quite a bit of severe weather. It was pretty successful in getting active weather out of our live weather scenario, just going where the weather goes. And we also did 22 total DSS events that led to 52 messages being sent to these simulated partners, along with 27 graphics that were made in support of them. We had 68 blog posts, which are forecasters writing their reflections and their thoughts on the products and what they observed, along with our daily and weekly surveys, and then about 15 hours of discussion in total for the week. So we have a lot of data that we collect each year and we're able to sift through. And so one example that you can see in the bottom right, as that will hopefully loop through there, is was an example of the of the products moving through and forecasters issuing warnings on a severe event that we had there in the Greenville, Spartanburg, and also Knoxville offices for one of the days. All right, and if we go to the next slide, I've talked about the overall test bed, but I also want to need to talk about what products we actually tested in there. This year we tested 3 total products. I'm going to introduce each product and then talk about kind of the reactions, the feedback, and some early takeaways that we have. So the first product that we demonstrated this year was GREMLIN. That stands for the GOES Radar Estimation via Machine Learning to Inform NWP. So it's not anything that you have little gremlins or anything running around in the computers or doing anything. This is a synthetic reflectivity estimate derived from satellite imagery using the AVI and then also GLM data into a machine learning model. This was available on the GOES East and West CONUS and mesoscenes. Last year, we demonstrated GREMLIN on the full disk, and forecasters really wanted to see this on these more limited scenes to gather more frequent updates, and they were able to accomplish that and have that deployed for this year. Key applications for GREMLIN. Its initial intent was for initializing convection in NWP, and so in weather models, and doing that ubiquitously across the scene. But also, when an intended application was also having radar data in areas that either had little to no radar coverage, and being able to leverage a product that provides something that's a derived quantity out of the satellite imagery itself. Additionally, monitoring for initiating convection as well, being able to utilize satellite signals for initiating convection, and how that translates to the reflectivity products, and maybe can lead those ground-based radar features and those observations a little bit there as well. So those are the key questions that were being asked for this year, especially the second and third ones there. So if we go to the next slide, we had a lot of talk this year about the mesoscale scene data. Forecasters liked using the 1-minute data for identifying updraft trends and changes in the overall intensity of convection. It was found, though, in the first 2 weeks of our testbed that on the mesoscale scene, as you can see there in the top left corner of this animation, can be a bit jumpy, particularly related to the lightning data that was being ingested at a 1-minute interval. Also, in some cases, as this is a low top convection case in central Illinois, there were also some cases where reflectivity values were a little bit underdone by GREMLIN overall. So along with talking about things like how the model is trained, also the changes were made to increase the amount of lightning data that was ingested into GREMLIN from 1 minute to 5 minutes, and that seemed to help, and that matched the CONUS level data, as you can see there in the bottom right corner of that animation. To go to the next slide, we can talk also about the GREMLIN meso data. We're looking at the 1 and 5 minute GLM totals and how that can impact, especially the reflectivity estimates. So this is an example of a supercell in northwest Texas or northern Texas here that had very high reflectivity values from the ground-based radar, as you can see there in the top right corner. And you can see a pretty prominent satellite signature there as well, with the overshooting top in the bottom left-hand corner from that IR imagery. On the top left there, the GREMLIN values from meso were, again, a little bit underdone overall, but they were near their maximum value of about 60 dBz. And when forecasters recognized that the maximum value for GREMLIN was 60 dBz based upon the output, they were able to calibrate to those values and recognize that as an important feature. There were some cases you can see in the bottom right-hand corner where we actually had GREMLIN values exceeding 60 dBz. That was another, and while that was unexpected, forecasters also used that as another indicator of the of intense convection and being able to provide any kind of warning decisions and monitoring. If we go to the next slide, I believe now we'll start switching over and talking about warning in areas that have little to no radar. With GREMLIN, it provides radar data where maybe you don't have any. And so we did a few cases this year, I believe 3 to 4 in total, where we gave forecasters a forecast area and then didn't give them radar data to look at. And so they were forced to use their satellite data and other observations to provide warnings along with DSS messaging as well. Along with using increasing reflectivity trends, as we mentioned earlier, from the satellite imagery and from other products such as OCTANE, which I'll mention in the next section. Also being able to communicate hazards when no radar data were available. So being able to provide an image from OCTANE and have a partner that can readily understand, okay, this is where you have more intense convection because it's a radar estimate product, provided some nice communication balance there overall. Additionally, forecasters mentioned that because GREMLIN is not parallax corrected at present, that they would like to see that as well. It would help with communicating locations, and then also when issuing warnings as well. In any kind of features based off of GREMLIN and not having to account for that using other features such as ground-based lightning networks. So this forecaster here on the right mentioned that using GREMLIN in this case, where they were able to suggest that they may see a hook on this storm, especially looking at GREMLIN along with their available satellite imagery, and then they issued a severe thunderstorm warning with a TOR possible tag available in that blog post. Next slide, please. So when thinking about our radar data quality, we asked the question of how useful is GREMLIN? We generally have found that GREMLIN is most useful in areas with little to no radar coverage based on group discussions, but we wanted to find ways to quantify that. So we asked some questions in our daily surveys last year and this year, looking for that transition. And while this is overall, while we are trying to gather information directly here, if looking at this overall in a qualitative sense, we do begin to see a transition here as the radar coverage becomes worse, that GREMLIN does become more useful overall, especially when you get into the areas with little to no radar coverage. So we'll continue investigating GREMLIN applications in those kinds of areas. Next slide, please. So some takeaways from GREMLIN. As I mentioned, is most useful in areas with little to no radar coverage, along with parallax correction, was also desired to increase warning and then the communication abilities of that product. As we move to the next slide here, we'll now transition to talking about OCTANE. So OCTANE is the optical flow code for tracking atmospheric motion vector and nowcasting experiments. This uses the textures and the motions in satellite imagery using visible and infrared bands to derive cloud top wind fields at very high resolutions, 1 minute imagery from the CONUS or from the mesosectors, along with at about a 0.5 kilometer resolution. Several products there include things like speed, direction, cloud top cooling, and cloud top divergence that can be derived there as well. So we have the speed and direction that are natively from OCTANE, and then further derived products there, the cooling and the divergence. So on the top right there, we can see the speed product, along with on the bottom right there, the divergence and the cooling. So as you go from the cooler colors, the blues and the greens, you transition to faster colors there as you get into your oranges and reds. With the divergence fields, you'll see a transition there from the purples into the pinks, and then from cloud top cooling, it features more like a stoplight product where you have green to yellow to red as you get into greater rates of cooling and glaciation. Intended applications include mesoanalysis, so looking at shear, and also localized ascent in environments, especially as you have initiating convection. You'll then see, especially in sheared environments, you'll then see increasing cloud top speeds there as well, along with monitoring updraft intensity through things such as divergence and then also the cooling, whether that's directly through the speed and direction products or using the derived products as well. Some major objectives and ones that I'll talk about today are the intended smoothing of the cloud top divergence fields. We tested 3 different flavors of those this year to see if that could help reduce some noise in the product and increase the utility, along with using CONUS data and producing that through OCTANE to provide a synthetic 1 minute imagery product that we called Meso Anywhere. And I'll briefly explain that in the following slide. So we'll go to the next slide here. And so talking about those different flavors you'll see of cloud top divergence and their smoothing, this is an example here where we can see the OCTANE speed versus the divergence of no smoothing, low, and then also high smoothing. While using things like speed, divergence, and cooling were used for CI along with monitoring the convection, forecasters found generally most useful in the daily and the weekly surveys. The low smoothing was the overall winner. I will state, though, that no smoothing was not all that far behind, especially when you consider all of the forecasters that were unsure of which one they felt most confident about in those products or in the different flavors there of the divergence fields. And in some cases, forecasters said that they started the week liking low smoothing because they removed the noise, but as they got more used to the divergence fields, they then began to transition over to using the no smoothing in some cases too. So there is a mix there as well, but low smoothing ended up being the overall winner if we had to crown one out of the mix. We'll go to the next slide, please. So new this year from OCTANE, and one that was interesting for forecasters to look at, was a product called Meso Anywhere. This uses the OCTANE motions from CONUS level imagery, and then it vects those satellite observations forward in time to provide essentially a 1 minute imagery that would be akin to your mesoscale scenes, but within the CONUS domain. This year we did a movable domain with data from the ABI channels in the visible at 2, and then in the near infrared at 5, and then the long wave infrared at 13. This also allowed us to create the day cloud phase distinction RGB. And so we asked forecasters in our pre and post testbed surveys to identify which imagery was real from the EBI and which one was the fake data from the Meso Anywhere, and being able to overall encounter that. So we'll go to the next slide here and show some feedback there from the Meso Anywhere products. Forecasters generally found that this product was most useful when the ABI mesosectors were unavailable. While at times the imagery could look very similar, it was best, the Meso data, of course, was the most direct observation that they were able to gather, but the ABE, or the OCTANE Meso Anywhere product, still provided them useful information, especially when gathering the 1 minute data for thunderstorm intensity trends here, and how much this matched, especially in more of this kind of regional view, and being able to match those trends overall. Forecasters also showed a pretty high level of confidence. Mostly they would respond with medium and high levels overall in the product, and being able to use it because it reflects the satellite imagery that they already know and love and are already using regularly in their WFO offices. If we go to the next slide, there's some additional feedback we have on OCTANE. In cases where you have rapid CI or are observing features on more of the storm scale, you will get at times a wave-like pattern as new CONUS imagery then becomes available. And so you establish kind of your new truth set, and then you eject that forward. And when you have those kind of rapid changes, some forecasters noted that that could at times limit the interpretation of that product when it was a little bit more jumpy in those cases. So it's not a one-to-one match of what you would see from your ABI mesoscale scene data, but you are still able to gather those trends with time using the 1 minute imagery and that overall advection there. We'll go to the next slide, please. So some takeaways from OCTANE. The light smoothing product was overall the preferred product. Some did still use the no smoothing and liked seeing just the direct outputs, but light smoothing overall was considered the winner. From Meso Anywhere and looking at that new product for the first time in the test bed, this was useful, especially when ABI imagery was unavailable, or maybe you only got half of a mesosector in your area or partial coverage from a mesosector. So in those scenarios, it provided some additional flexibility in being able to leverage higher resolution imagery, especially on the 1 minute temporal sense there. So we'll continue on now and talk about our last product, which was the ProbSevere LightningCast version 2 on the next slide here. You may already know about ProbSevere LightningCast as it is currently operational. That version 1 provides 1 hour lightning probabilities using several ABI bands. But it also provides, but also this year, version 2 provides information from the MRMS negative 10 degrees Celsius reflectivity product. So very similar in its structure overall, but is providing that information also now from a radar data source. Expected improvements include CI under dense cirrus, or maybe those visible, or maybe those scenes from the satellite point of view are obscured of that convection, along with more marginal cases where maybe you have less hydrometeors being lofted into the mixed phase region, but still have colder cloud tops, especially in the colder seasons or at nighttime convection, along with looking at lighting cessation as well. So applications are going to be very similar to what you would observe already with LightningCast version 1, which is initiating convection, using it as a DSS tool there to provide lightning-related hazard and communication, along with using lightning dashboards as well that have been tested also in the HWT before. This year we tested those also side by side with version 1 and version 2 at various points. Version 1 there will be in red, and version 2 will be in green. So comparing version 1 and version 2 in the next slide, we can start to really gather into these differences here. And so forecasters found that version 2 in general could identify lightning potential a little bit sooner than version 1. It was not always that case, but it was in a pretty wide variety here. When asking forecasters in our daily surveys which version gave the longer actionable lead times, you can see there in the bottom left, version 2 won out quite a bit, though there are a number of cases where they were about the same and the forecaster felt that they were fairly comparable. They also found that the version 2 probabilities tended to increase and decrease more steadily, even in the 5 minute CONUS data, which was the only data set that they had available this year in the test bed. And so having those steady increases and decreases in the probabilities that provided additional confidence when they communicated that information. Next slide, please. Additionally, when looking at LightningCast in that area of dense cirrus, such as you can see in the blue circle, those obscured signals from the satellite imagery can also provide that extra information for the forecasters. And we can see that here in this comparison of version 1 and version 2 at the bottom there, where you have increasing probabilities there leading up to that initial lightning flash. Though when you have the impact of poor radar data, also that could change how version 2 interprets poor radar data quality. You can see over in the example on the left-hand side there in the red circle. LightningCast version 2 is using a binary classification of yes, no in terms of the data that was available. And so in some cases you had data available, but it was fairly poor. And that was reflected in the lower probabilities from version 2. And so there was quite a bit of rich discussion that was had in the experiment of what we do or what can be done to improve LightningCast version 2 in that product. And so it was brought up, well, rather than using a binary classification, looking for a range of values, and one of them being the example being the MRMS radar quality index, or even just understanding and having a location from the nearest WSR 88D as well in those kind of fields. So there's a few different ideas that were thrown out there for how to improve that classification of your radar data quality, and provide that as an avenue of improvement for version 2, even further than what it already has for over version 1. Next slide, please. We also assessed the LightningCast dashboards. Those were on-demand dashboards that were already set. They also, or that were set for them, they could then fill out a form and then receive a link to a web page to have that. There also were static points that they could use, mostly at stadiums or at TAF sites as well. Version 2 again gave earlier confidence for lightning onset, especially in this example here. You can see that the LightningCast version 2 probabilities picked up a bit sooner than version 1 there overall. Other ideas that came out of the dashboards were ideas such as if there could be an inset map to show probability spatially, could you show multiple points on one page? So that way, for offices that maybe have multiple events going on at once, they could monitor those, along with variable range rings or maximum probabilities within those areas to provide more spatial information, even in the dashboard format. We'll go to the next slide here. We also this year, after the first week, our LightningCast developers made a visualization change and looked to do some new LightningCast color contours. The motivation was to leverage existing color scales from the NWS, specifically taking kind of a page out of the Storm Prediction Center's kind of range of values here as you go from the lower probabilities and lower categories from the greens up to the orange, reds, and pinks there in the higher levels. And so they then changed their color contours after the first week to then reflect that in the probabilities there using those values. Forecasters found that this was pretty easy to translate to their public and then to the partners based upon this scale, and provided additional communication. We can see that in the example in the bottom right here. This was a graphic from the International Balloon Festival that they were doing a simulated event for. And they were able to provide those probabilities directly within their readout there and in that product. Forecasters also took this one step further and thought, well, if SBC can do filled contours, why can't LightningCast? And so they went in and they were able to create a filled contour product as well when comparing these version 1 and version 2, and looked at that information and how it translated to the graphics that they were able to also communicate as well. And it's received overall positive feedback. So going to the next slide here, I believe it's just wrapping up our early takeaways there from LightningCast here. Improvements in the areas with dense cloud cover, and then overall trends were really where LightningCast version 2 stood out. There's additional avenues for growth there as well in the visualization, but then also adding that new color scale was well received by the forecasters. And that is available even in the online product now there. If you're looking at LightningCast via Real Earth. This is some early takeaways right now. More will be coming in the testbed final report in August and September. That'll be coming out. I'm going to post 2 links here into the chat. One of them being the blog post from our experiment. So if you want to go in and you want to read direct feedback written by the forecasters themselves, you can do that at this blog. Also, you'll find in the second link there are the reports the reports from previous test beds, and the new one will be put there once it's published. And I'll try to share that as widely as possible here. So also wrapping up here, it's just some thoughts on future experiments and where do we go as a test bed from here. On the next slide, we are looking to return to on-site demonstrations when we can. It's an invaluable portion of the research to operations and operations to research process. We can meet many of our core objectives using virtual experiments, but we really are excited to get back to on-site demonstrations when we can. We also are asking questions like, how do we get the most out of operations each day? So we're never going to try to run the same test bed twice to really try to maximize our utility for both the forecasters and also for our developers. So if we want to reorganize or reorganize our schedule and reorder it by breaking it into sessions or providing flexible start times. These are avenues that we're looking at as well. This year, we also did a pre-test bed surveys and got some nice information out of that. So we're looking to align that in the future with our post-test bed surveys, especially how do we assess our pre-test bed training materials and assess that utility will be a really fun avenue to explore. Along with making sure we're maximizing our radar denial opportunities and how we can exploit that best overall. In many cases, forecasters are very used to providing warnings by using radar-based methods, as that was been the heavy focus of the training. And so by doing these denial opportunities, it provides a way that we can kind of break the training a little bit, but also provide information in the satellite objective to be able to fit that in our limited window that we have them for each week in the test bed. So wrapping up here to finish off, I have just several acknowledgments that I want to give on the next slide here. We had many forecasters, product developers, and also visiting scientists that were a part of this test bed. It's usually about 30 to 40 people. So I'm usually the one providing these updates and writing reports and everything. A lot of the really hard work and a lot of the value comes from all of these people that are providing this as part of the test bed and as part of and be able to provide more information to improve satellite products. So a big hats off and thank you to all of them for all of their contributions. Additionally, Justin Monroe and Jonathan Madden, our AWIPS developers, ran our cloud AWIPS instances and did another great job of doing that and making sure that we were able to get all of our data feeds established, working with our developers and making sure that we were able to run our test bed very efficiently this year through the cloud AWIPS platform. Additionally, I want to provide acknowledgments for CIWRO, SBC, and NSSL for their continued support, along with the GOES-R Proving Ground for funding this work and this project. So that's all that I have. We'll go to the last slide here. I want to thank you all very much for your time and attention today. And so I want to end out here on a loop of just kind of showing the tour of the satellite experiment this year and all the places that we went on this tour. So maybe we ended up in a CWA near you. And you can see that as we move throughout the country each day relative to our convective outlooks and where we went each day based on the weather. So thank you very much. And I'm happy to toss it over to the facilitators and start our Q&A.
Okay, thank you, Kevin. That talk was great. And just to dispel any confusion, I'm actually sitting in the same room as Kevin right now, so I'll be facilitating through Kevin's mic here. I just want to say congratulations again, Kevin, on receiving your PhD recently, as well as congratulations on the track you're on to become a research scientist here.
Thank you.
So a lot of interesting things. If you have questions, I'll encourage you to go ahead and post them to the Q&A now. We'll go ahead and get started. Let me hold on. I got to pull up the script here. I just wanted to say before we actually turn to the audience for questions, there are some friendly reminders. To view the facilitator and the presenter during the Q&A, please change your layout from tiled to hide tiles without video. That'll help you see who's talking here. And then in 1 week, on Thursday, July 17th at 12 p.m. Eastern Time, we'll have Jenny Descend from NCEI presenting on the boots on the ground in Asheville, North Carolina during Hurricane Helene. So that'll be a very interesting talk to watch. And if you have any questions about Satellite Book Club or satellite products, you can contact Sheila Kupai from the Tower S team. So now let's go ahead and turn to some of the audience questions here. And I'll actually go ahead and start with the first question that's come in from Kenneth, which says, thanks, Kevin. Where the radar quality is very good, might LightningCast weight it higher than nominal?
Trying to understand, let me make sure I understand that question. So when radar quality is overall good, it's as long as you have the same signals, you should get similar probabilities between version 1 and version 2. Though with that additional radar information, then it may come in higher because you're getting that additional information from your radar data overall. So hopefully that answers that question. If not, I'm happy to clarify that. But with LightningCast, yeah, by providing that, it will be maximized, especially those differences that you'll see, especially in areas like dense cirrus, the biggest advantages and gains in areas where the radar quality overall is the best.
All right, we have another question from Dan Lindsay. One goal of the hazardous weather test bed is to advance the readiness level of experimental products and prepare for their possible transition to ops. What's your take on whether any of this year's products are ready, are near ready for transition?
That's a great question. I would default back to what the forecasters are giving in their feedback this year. What we're seeing, especially, I see LightningCast version 2 absolutely has an avenue to move towards operations. I think there still can be gains made, and there's some great discussion we had with the forecasters about avenues from what they saw in the test bed to make even improvements before version 2 becomes fully operational. If it receives funding and is able to find avenues for operationalization, and then in addition. Also, it seems the OCTANE products this year as well are beginning to gather additional steam and really beginning to refine those products further. So this year we focused less on, with OCTANE, are the products usable and are they good? We focused more on how we can maximize their display, their improvements, and finding additional avenues there as well. So you can see these transitions that happen year to year when we have products that are able to cycle through 2 to 3 years here in the test bed. And so, yeah, those products have the avenues there, and forecasters are beginning to show more support. So from the overall feedback from those forecasters, LightningCast and OCTANE are probably the two that have the most clear pathways. GREMLIN in some ways I feel does, but I can see where there could be additional avenues or more specialized deployments that maybe don't get done in the entire weather service. But that's, again, kind of one of those things that's above my pay grade. I'm just here to say what the forecasters are showing me on that regard. That is a really good question of, which ones should come out, which ones will come next. And I'll try to emphasize that as much as I can in the forecaster-driven recommendations.
All right, we've got a very active question and answer session right now. Next question from Sean here, Sean Helfrich, is 2 questions. What impacts would the lack of GLM have on GREMLIN? And second question, what impacts have you seen by the lack of parallax correction for GREMLIN?
Yeah, those are good questions. And so answering the first one here about the impact of the lack of GLM data on GREMLIN. So GREMLIN data, from talking with the developer, Kyle Hilburn, that GREMLIN really will use this lightning data, the presence of that data, along with increasing flash rates, especially in what they use the group densities from the GLM. That's able to further bolster reflectivity values and provide additional confidence for that model of areas where you have greater reflectivities that you would expect in those areas. So if you take away the lightning data or reduce it by using a shorter integration time, you're then getting less confidence out of the model, and so that's going to reduce, or that's going to result in reduced reflectivity values or more spread out values overall. As it muddies the waters a little bit when you are missing that information there. When asking about the impacts that you've seen, or that I've seen from the lack of parallax correction, many of those impacts are forecasters having to physically adjust, especially as they're working on the warning scale, where those warnings are matters, their placement and the hazards, and being able to not overwarn areas. Forecasters generally understand that if you're only using radar data or only using satellite information to provide warnings, that the warnings maybe need to be a little bit larger to account for those differences. But being able to reduce their overwarned areas or false alarm areas around warnings is, I think, one of those valuable pieces. So forecasters also sometimes weren't expecting the parallax correction to not be there because it is a reflectivity-based product, and they actually didn't account for parallax initially until the first few warnings. So that was one of the things that had to be clarified as well for those forecasters. So just the location of those warnings and being able to fine-tune those is something that forecasters really wanted there.
All right, our next question is from Christopher Smith. And he asks, are OCTANE or LightningCast version 2 product configs available to test in AWIPS for other centers? And I'll just add on to that. Are there places where you can find these products online that have been tested as well?
Yeah. So yeah, answering the first part of that question there, those products, because we've got them into an AWIPS format, there are configurations that are available, and I would recommend reaching out to the developers in order to do that. That a lot of those will be done through non-operational feeds, maybe through an LVM, and the connections based upon those setups there. Actually, I'll give as an example. We're actually, and the reason why Jason is sitting next to me here in Norman and not up in Fort Collins is that we actually are kicking off a demonstration here at SBC of the OCTANE products and their applications and utility to gather the feedback here at a national center and somewhere that's kind of outside that initial purview. So those collaborations can exist. I would recommend reaching out to those developer groups and those people. And if you'd like to know those individuals, I'm absolutely willing to kind of route you and connect you to the right people there. And then the next part of your question was about where these are viewable online. So LightningCast products, you can find those on Real Earth. I'll make sure I find the link for that. We can throw that in. And then also OCTANE products are available in Sierra Slider under the mesoscale scenes. And GREMLIN right now does not have an initial. Thank you, Mike, for that LightningCast link. And the GREMLIN right now doesn't have a true front-facing. There's a CONUS-scale scene image, I believe, that you can find on the Sierra website, but I can look and find those as well.
And we have one great question, I think, from Mike Pavlonis. Any thoughts on how the HWT can facilitate the formulation of formal requests for the products successfully demonstrated? Operational transitions are largely driven by formal requirements.
How the HWT can facilitate the formulation of formal requirements for the products. That's a really good question. That's a big question. So that might take me a second to figure out, how to facilitate that formulation. Well, there are some avenues that we have now that we are trying to really specify what developer groups are getting after and make that clear for everybody. One of those we've done in the last 2 to 3 years are the creation of these R2O questions. And so these questions are submitted by the developers, and then we have a discussion about what's appropriate for the test bed and how we can then better inform that. And so those R2O questions that are provided by the product developers derive our evaluation. And then my job at that point is to take those questions and figure out how do we answer those in a way that is more formal, is qualitative and quantitative in as many ways as possible. And being able to have those kinds of, being able to show that we're meeting those markers of development and growth that fits for those developers. In creating formal requirements, that's a great question that I don't know a good answer to right now. I'd happy to default to anybody else in the room on that. But in terms of creating formal requirements, that really is, I believe, it would be done more by those that are responsible for the satellite portfolio management, looking at those products and the feedback from the test bed, and then being able to begin the discussions of how we get these products to higher readiness levels and have those discussions. So in our case, I think we're taking what we have and what we find and being able to begin the discussion and create that kind of dialogue in the pathway here from the research products and transition them into operations. That was a bit long-winded, so if you have any other follow-ons there, but it's a big question, and creating formal requirements is typically kind of beyond what I'm traditionally doing in this role. But it's something that I think would be really exciting to have.
All right, that is a great question, and I see we've reached the end of our time here. So I just wanted to thank our speaker one last time. And with that, we'll go ahead and transition back to Dan for closing remarks.
Yeah, thanks. Let me say a couple quick words about Mike's question about the requirements process. I don't have a firm answer, but I will say that I think any new requirement for a new product starts with getting weather service buy-in and weather service requests. So I think you guys that are weather service folks, if there's something that you see that you really like, you really want to go into operations, pass that up your management chain, and that at least will start the process. I'm not guaranteeing that that's going to ultimately end in a requirement, but do that, and that's always I think step one, at least in the transition to ops. Okay, so again, thank you so much, Kevin, for a great presentation, and thank you, Jason, for your facilitation. Just a quick reminder that next week, the Satellite Book Club session will feature Jenny Disson from NCEI presenting on the boots on the ground in Asheville, North Carolina during Hurricane Helene. So thanks, everybody. Talk to you next week.